You are given a string S that forms a valid arithmetic expression. It may contain digits, plus, minus, multiply, divide, and parentheses. Your goal is the integer value of the fully evaluated expression. Example 1, 1 plus 1. Read the first one, that is our starting value. The plus sign adds the next one, so 1 plus 1 equals 2. The expression evaluates to 2. Example 2, 6 minus 4 divided by 2. Division binds tighter than subtraction, so 4 divided by 2 is 2 first. 6 minus 2 finishes at 4. When scanning a mathematical string, parentheses act as an instant hardware override. The moment our character scanner hits an opening bracket, it drops a shield blocking the rest of the expression. It spawns a brand new, isolated calculation environment that must be completely solved before the main timeline can move forward. Instead of writing complex tracking rules for different levels of brackets, the engine simply clones itself. We use recursion to spin up a fresh, independent subcalculator. This child calculator evaluates its given sub-expression using the exact same standard rules, completely unaware of the larger equation outside. Inside the sub-engine, numbers and operators are parsed into a local stack. Low precedence operations like addition or subtraction are held passively in the stack as signed integers, while high precedence operations like multiplication or division would be calculated instantly on the fly. Once the substring ends, the stack collapses into a single scalar value. The subcalculator terminates and passes its finalized result back to the parent. The nested brackets dissolve, replaced completely by our single integer bubble. The parent calculator lifts its shield, treats this bubble exactly like a regular scan number, and resumes its execution loop. Now back in the main loop, the high precedence multiplication fires instantly. The numbers are crunched on the spot, bypassing the addition stack entirely, updating our active state before the final subtraction is even evaluated. With all operators processed and the string exhausted, the main stack performs its final sweep. It sums up the remaining terms, leaving us with our absolute finalized answer, 9. We kick off our coding implementation by constructing a multi-track execution dashboard. At the top sits our controller code with a shared read index POS. In the center track, we lay out the full string S as indexed characters. At the bottom, we initialize an empty stack alongside sign and number trackers. POS starts at 0. Each loop iteration reads one character from S at POS and advances POS immediately. When that character is a digit, we extend number, multiplying by 10 each time to handle multi-digit values naturally. When CH is an operator, we commit number under the previous sign. Since sign started as plus, we push 2 onto the stack, store star as the new sign, and reset number to 0. When CH is an open parenthesis, we recurse on the same string S. The shared POS has already stepped past the bracket, so the child call continues from the next character. The parent execution track freezes and dims while a clean subcalculator handles the inner expression. The inner loop breaks on the closing parenthesis, POS is now past it. The recursive call returns 7 into number. The parent wakes up, unfreezes its memory track, and treats that 7 exactly as if it were a freshly read digit. Next, our pointer lands on the trailing minus operator. We check our active sign register, which is holding a high precedence multiplication sign. This requires immediate execution. We pop the top element from our stack, multiply it by our current number 7, and commit the evaluated result of 14 right back onto the stack. With the input string fully exhausted, the main loop gives way to the final stack sweep. We pop and add every remaining sign value until one total remains, then return that sum as our finalized answer, 9. Let n be the length of the expression string. Time is order n, because each character advances the index once across the full parse. Space is order n in the worst case for the value stack plus recursion depth when parentheses nest deeply. Here is the recursive calculator from the solution in pseudocode, a shared read index POS, a stack for signed terms, and call calculate whenever we enter parentheses. Declare global read index POS starting at 0. Define calculate on the input string s. Create an empty stack, number buffer, and default plus sign. Loop while the shared index POS is still inside s. Read the current character and advance POS in one step. If ch is between 0 and 9, it is a digit. Multiply number by 10 and add the new digit. If ch is an open parenthesis, recurse on the inner expression. The recursive call returns one scalar into number, POS keeps moving forward. If ch is an operator, commit number using the previous sign. When sign is plus, push number as a positive stack term. When sign is minus, push the negated value. When sign is multiply, pop the top and push the product. When sign is divide, pop the top and push the truncated quotient. Reset number to 0 and store the new operator in sign. If ch is a close parenthesis, this frame is done. Break out of the loop and return to the caller. After the loop, push a positive trailing term when sign is plus. Push a negative trailing term when sign is minus. Crunch a trailing multiply with the stack top. Crunch a trailing divide with the stack top. Start the final total at 0. Drain the stack until it is empty. Add each popped signed term into total. Return total as the evaluated value.